Probably no one would have thought that this simple game hides an inexplicable physical phenomenon. Hold one end of a rope with a small ball attached to the other end and swing the rope so that it rotates on a horizontal plane. We can only identify three forces in this movement: the centripetal force, the centrifugal force, the gravitational force. This raises the question of how these three forces can be balanced dynamically so that the rope rotates in a horizontal plane. To achieve this balance, an upward pulling force is required, of course, whose strength must correspond exactly to the gravitational force. So where does this force come from? Who would have thought that our scientific knowledge of the 21st century cannot explain this simple phenomenon? Anyone who thinks this is a trivial problem is mistaken. Because it's about fundamental physical knowledge. If the foundation is flawed, the building built on it can wobble. Some believe that Newtonian mechanics has been fully explained and that classical mechanics is outdated, inadequate, and uninteresting. Is this really the case? Or are we overestimating ourselves? In the following, we will examine this using a few examples. As we know, a rotating body, such as a gyroscope, remains stable in its axial direction. This property has been widely used. However, its puzzling behavior has not yet been deciphered. Obviously, this is merely a matter of knowledge of classical physics. All surreal grand theories are useless here. We know that every moving mass body has an inertial force. The effect of inertial force is that the body resists the action of external forces and remains in its state of motion. Obviously, there must also be a force here that allows the gyroscope to remain in its acrobatic position. And there is no doubt that this force is generated by the rotational movement, because if it stopped rotating, it would immediately fall down. Movement generates force? For many, this still seems to be a completely new thesis. On the surface, it seems as if there is an upward force that resists the Earth's gravitational pull. If this is the case, then the magnitude of this force is independent of the length of the gyroscope axis. However, if the axis of the gyroscope is extended to a certain length, this position of the gyroscope definitely cannot be maintained at the same. As can be seen in the figure, there is a torque M that forces the gyroscopes to bend. In order to resist this torque, the gyroscope must therefore have its own torque, which we call the torque of inertia, in order to maintain the direction of its axis of rotation. This makes the problem even more mysterious. Explaining how a rotating object generates its own torque of inertia and exactly how large this torque of inertia is still exceeds the capabilities of our scientists in the 21st century. We all know that Newton's first law, also known as the law of inertia, only applies to linear motion without the influence of external forces. And such motion does not exist in reality. And since the gyroscope involves pure rotational motion, there is no way to apply Newton's laws. In order for physics to develop correctly and healthily, we must therefore first remedy the inadequacies of the fundamental laws of physics, Newton's laws. In reality, a straight line is a special case of a curve. That is, when the radius of a curve is infinite, it becomes a straight line. Similarly, straight line motion is a special case of curved motion. And curved motion is the general state of motion, which also becomes linear when the radius of the curve is infinite. That is, there is no clear boundary between linear and curved motion, both are continuous. In some physical theories, linear and curved motions are considered two independent states. This alone shows that such a theory may be incomplete, if not incorrect. A perfect theory must be able to explain the rules of motion in the general state, i.e., in the curved state, and it must also apply to the rules when the radius is infinite, i.e., in linear motion. As already explained, a massive body possesses a natural property, inertia, and it is the only property that matter has. The function of inertia is that a moving body resists the influence of external forces in order to remain in its state of motion. It can be shown that the magnitude of the inertial force of a body is proportional to the square of its velocity and to its mass, and inversely proportional to the distance from the external force. It can be described by the following equation. So with this force, a body remains in its state of motion. As long as the properties of inertial forces are integrated into Newton's first law applies to motion in a general sense. Thus, Newton's first law is generalized. In fact, force and motion are the fundamental elements of physics, and all natural phenomena can be traced back to the results of the two. But what exactly is force? How is it generated? So far, no one seems to be able to answer these questions correctly. Newton's second law defines force and describes it with the following mathematical formula. The physical meaning of the formula is that a body is accelerated by a force, i.e., the speed of the body is changed. Conversely, if the speed of a body changes, a force is generated. For example, when a boxer hits his opponent and generates a force, this force can knock the opponent to the ground. However, if the opponent dodges the punch, no force is generated, only a rapid movement of the fist. This means that only when the movement of a body is impeded does its velocity change and a force arise. Newton's second law is also derived under ideal conditions. And such ideal conditions do not exist in reality. This means that, like Newton's first law, it only applies to linear motion without the influence of external forces. It is therefore also imperfect. As we explained above, every moving body generally, in curved motion, has an inertial force whose function is to resist the influence of external forces and maintain its state of motion. This means that when a body is accelerated by an initial force, this force is more or less reduced by the inertial force. Therefore, the effective acceleration force on a body is equal to the initial acceleration force minus the inertial force of the body. In general, the velocity equation for an accelerated object must therefore be replaced by the following equation, instead of the equation normally used to determine the velocity of an accelerated object. Since the velocity v of the accelerated object increases with time, the following equation results. Solving this equation yields the following maximum velocity that an object accelerated by can reach. This means that the velocity of an accelerated body is finite under the influence of inertial force. It can be expressed as follows. This equation corresponds exactly to the well-known formula for centrifugal force. This means that a rotating body generates centrifugal force. And centrifugal force is a special case of inertial force. It is a real force and not an apparent force, as some believe. Then the following equation, which we normally use for the velocity of an accelerated object, applies, no longer in the general case, but only in the special case, i.e., only for linear motion. The well-known differential formula for acceleration also loses its general validity. This means that Newton's second law is only complete when the inertial properties of the body are taken into account. Or we can extend the equation for Newton's second law as follows. Only now that we have generalized Newton's first law of motion and the second law of force can we re-explore other physical phenomena. And all theories and laws of physics that relate to motion and do not yet take inertia into account must be reconsidered. In fact, the accuracy of all those theories and laws that were derived before the generalization of Newton's laws is doubtful. We know that all celestial bodies in the universe revolve. This is the most fundamental motion in the sky. If we cannot explain why celestial bodies orbit at all, then all explanations and interpretations of events in the sky must be questioned. Even according to the theory that the Earth's orbit around the Sun is caused by the curvature of space, this would only be possible if the Earth were able to move at all. We must unconditionally accept the reality that no object can move forever without force. Kepler used the gravitational force between the Sun and the planets to derive the orbits of the planets around the Sun. However, the gravitational force between the Sun and the planets alone could have resulted in nothing but mutual collisions. This is an indisputable reality. The reason why the planets revolve around the Sun is actually quite simple. When the Sun rotates, its gravitational field, which we call the rotating gravitational field, naturally rotates with it. When the Sun attracts the Earth with its gravitational force and rotates at the same time, the Earth is driven in the direction of rotation by the rotating gravitational field of the Sun. This is like an electric motor whose stator generates a rotating electromagnetic field that drives the rotor. We call this the motor effect. But why is such a simple and clear phenomenon not recognized by anyone? However, if the Earth's orbit around the Sun is driven by the gravitational field of the Sun's rotation, then the Sun itself must be able to rotate. This raises the question of why the Sun rotates at all. Here, too, the Sun cannot rotate forever without force, especially since it takes an infinite amount of energy to set all the planets in eternal motion. The rotation of celestial bodies can be explained simply as follows: when a body is driven by a force, its speed is accelerated. However, due to the body's inertia, its speed is limited. It cannot increase any further, as if the body were hitting a wall. Nevertheless, the force continues to act on the body. In order to release this force, the inevitable result is that the body rotates. We call this effect gyrotation, i.e., when a body accelerates, it also rotates. This phenomenon can be observed in many events, for example, in tornadoes and when bombs are dropped from aircraft. This means that the rotation of a body is caused by its accelerated orbit, and the orbit is in turn caused by the rotation. This raises the question, which came first? The rotation or the orbit? To explain this paradox, let's take a binary star system as an example. A binary star system consists of two stars orbiting each other. According to the condition that rotation is generated by orbiting and orbiting by rotation, they must move in two mutually orthogonal planes in order to be able to move with each other forever. The fact that rotation is generated by orbiting and orbiting by rotation is, in the truest sense of the word, the interaction between rotation and orbiting. This means that rotation and orbiting are simultaneous and can only interact with each other forever if they are connected in such a system. We have already explained that the orbital velocity can be calculated directly from this equation with asterisk, and the rotational velocity is also derived from this equation. This equation thus represents the mathematical form of the interaction between rotation and orbiting. This equation comes from inertia, which means that a body driven by a force moves, and this movement in turn generates a force, the force of inertia. The task of the force of inertia is to counteract all external forces in order to keep the body in a state of motion. The external force here is the gravitational force of the other star. We know that two stars orbiting each other resist each other's gravity with their own centrifugal force. The force that opposes the other's gravity is actually an attractive force toward the other. It is like two people connected by a rope spinning on a disc. They pull on each other without throwing each other off. And it is easy to calculate that the gravitational force between the two stars and their centrifugal force are exactly the same. This is no coincidence. However, gravity is a long-range force without contact, which means that there is no rope connecting them. In fact, we have absolutely no idea how a contactless long-range force works. But it does exist. If we blindly accept that centrifugal force is also capable of acting at a distance, then the essence of gravity is centrifugal force, the force of inertia. If anyone can figure out how long-range forces work, then it is highly likely that this principle of long-range force also applies to centrifugal force. The process of interaction between rotation and orbiting can also be described as follows: one star drives the other with its gravitational force, thereby setting it in motion. This motion in turn generates a force that drives the previous star. This also represents an interaction between force and motion. Motion, force, motion, force. If we omit the motion loop, then it is the interaction between force and force. This is the principle of interaction, through which force is generated. Its mathematical form can also be expressed in terms of the interaction between rotation and orbiting. A system such as a double-star system, which we call a sovereignty system, that does not require additional energy to run forever, like a perpetual motion machine. A mechanism that has been condemned by humans as impossible. But nature can do it. The conclusion, then, is that the essence of gravity is inertial force. The essence of Newton's law of gravity, according to which every point of mass attracts every other point of mass with an attractive force, is a vehement error in physics. This error leads the whole of physics astray. It is wrong because it does not explain where the energy necessary for the force comes from, and a force that is not supported by energy has no physical meaning. And the force generated by motion has energy equal to the kinetic energy of the body. We know that the strength of the gravitational force depends on a constant, the gravitational constant g. Let's take a look at how this gravitational constant comes about. We know that the gravitational force between two bodies m1 and m2 is as follows. And the strength of the gravitational field of m1 is as follows. And the velocity v2 of body m2, which is driven by this gravitational field, can be calculated from the equation with asterisk. We call this g the gravitational constant g1 for m1 and thus have the following equation. Similarly, we denote the gravitational constant for m2 as g2. Here, g1 and g2 depend on two completely different elements, their own mass and their mutual velocity. For two bodies of different masses orbiting each other at different speeds, the two gravitational constants cannot normally be the same. However, they must be absolutely equal for the system to function at all. This means that the gravitational constant can only arise by chance. Thus, it only applies to a specific system and is therefore not universally valid. Under certain conditions, such a system does not depend on the mass of the two bodies. Particles in the microscopic world can also form such a sovereignty system and generate forces on each other. The world's leading physicists are now desperately trying to unify all natural forces, that is, to find a theory of everything. If all natural forces can be unified, they must all arise from the same principle. Then, logically, they must all arise in the same way as gravity. As the equation with asterisk shows, the force is proportional to the square of the velocity of the body and inversely proportional to the distance between the two bodies. This means that the faster the particles move and the smaller the distance between them, the greater the force that arises between them. For this reason, the value of gravity appears so small in comparison. Let's take a hydrogen atom, which consists of a proton and a neutron, as an example to explain how the strong interaction is generated. If the strong interaction is generated by the interaction between protons and neutrons, then these must also be located in two orthogonal planes, just like the two stars in a binary star system. In order for the neutron and proton not to stick together due to the attractive force of the strong interaction, they would have to orbit each other at approximately the speed of light. The principle of interaction therefore states, force generates motion and motion generates force. This means that the strong interaction is generated by the speed of light. And from the above principle of generating the gravitational constant, the gravitational constant of this hydrogen nucleus can be easily derived as follows. Incidentally, when protons and neutrons move at the speed of light, they have a kinetic energy as follows. This is the energy that could be generated by splitting this nucleus without sacrificing mass. With this gravitational constant for the nucleus of the hydrogen atom, the strong nuclear force can also be easily calculated using Newton's formula for gravity. As we have said, the core of Newton's law of gravity, which states that every mass attracts another mass, is incorrect. However, the mathematical formula of this law is correct. And all other natural forces can be derived in the same way. Then the so-called theory of everything can be expressed by the equation with asterisk. This simple equation not only explains the origin of all natural forces, including gravity. It can also be applied to classical mechanics. With this simple equation, we have also solved the mystery of the gyroscope, which no one has been able to explain until now. If someone could unite all natural forces with a super-complex mathematical equation that cannot be used for classical mechanics, it would be nothing more than garbage. I would like to emphasize once again that mathematics can only describe physics, but cannot replace or create it. In fact, this equation unifies the two most fundamental events in physics, force and motion. Ultimately, all physical phenomena can be traced back to these two events. This concludes our introduction to real physics. To understand the content of real physics in detail, we must first learn how to solve the problem of the accelerated ball. That means we must relearn physics from the very beginning under the strict logic and observe the following basic principles. Mass is a neutral thing that has neither force nor any godlike ability, nor can it be converted into energy. Energy is only a measure used to compare and study various physical phenomena. Concrete and tangible energy does not exist anywhere or in any form. Space and time are absolute. Please never forget, physics is a science.